I'm going to look at a few problems on Gas Laws Worksheet 2 that have been giving a lot of people a really hard time. And that would be problem number 1, problem number 3, and problem number 6. The thing you need to understand when you're dealing with equations like this, where they are giving you liters of one substance and they want you to find liters of the other substance, you're going to follow this general scheme right here. You're going to start with the liters of your first substance. Now, we know because of Avogadro's law that you can go from liters to moles of a substance if they're all at the same temperature and pressure. In this case, you're going to take the number of liters. You are going to divide by 22.4 to get number of moles. And then you can go up to the balanced equation. You can use the mole ratio to go from moles of A to moles of B. And then to change back from moles of B to liters of B, you can multiply by 22.4. And sometimes it's even easier than that. Take a look at problem number 1. It says for this reaction, how many liters of water can be made from 16 liters of hydrogen? So you're starting out with 16 liters of hydrogen, okay? You are trying to find liters of water. If you look up at your balanced equation, the ratio of hydrogen to water is 2 to 2. So basically what this says is that every 2 moles of this is going to make 2 moles of this. In other words, the volumes are going to be equal. So if I have 16 liters of hydrogen, it is going to make 16 liters of water. Don't be angry. It's just that easy. Now let's look at number 3. Given the following equation, how many liters of hydrogen are needed to produce 28.66 liters of methane? Okay, so we're starting out with 28.66 liters of methane. We are trying to find liters of hydrogen. Okay, now I'm going to come up here to the balanced equation. I'm going to see that there's 1 mole of methane made for every 2 moles of hydrogen that go into it. So my ratio of methane to hydrogen is 1 to 2. So even if I change this into moles, I know that I'm going to have twice as much of what I started with, and then when I change it back into liters, all I have to do is take this number times 2 to get this answer. I'm not going to tell you what 28.66 times 2 is, but I trust that you guys can do that. Now, a little bit different when we look at number 6. Number 6 is one of those Dalton's law of partial pressures questions where we know that the pressure total equals the pressures of all of the other gases added up. Now, since there's only 2 gases in this problem, there's oxygen gas and there's nitrogen gas. We know that the total pressure is 1 atmosphere, correct? And we know as far as amounts, we know that this is 0.3 moles. We know this is 1.2 moles. Now, if these gases take up equal amounts of space, if they've got equal quantities, then we can assume that the total number of moles of gas in this entire balloon is 0.3 plus 1.2, or 1.5 moles, right? Now, what portion of that 1.5 is made up by this guy right here? You can take that by doing part divided by total. So we do 0.3 divided by 1.5. Now, if this was 3 and if this was 15, then it would be a lot easier for you to see. Well, That's just 1/5 of it, right? 1/5 as a decimal is equal to 0.2, correct? So roughly 20% or 1/5 of that total pressure is coming from this oxygen. So 1/5 of 1, or 0.2 of 1, or 20% of 1 equals 0.2 atmospheres. And again, don't be angry, but those are just that easy. So, for future reference, don't get so caught up in the numbers and the examples. Look and see what the problem is really asking you and decide, okay, is this like one that I've seen an example of, or is this something totally new? In this case, it's new, but it's not difficult. Y'all have a great rest of the week.